Let's do a quick informal review of probability in this video. Probability is a way to measure likelihood of future events. Or another way to put it is a way to quantify uncertainty. So if you're taking coin flipping as an example, you know that you'll get either heads or tails when you flip the coin. But you'll not know the outcome until the coin is flipped. But if you want to say whether you are going to get heads or tails, you'll be relying on probability. You'll be using probability to say how likely it is that you are going to heads or how likely it is that you are going to get tails. Normally, probability is denoted using this function called P function. And the x which is passed as the input for this function is called a random variable. It is called a random variable because it represents the outcome of future event and we'll not know the outcome until that event happens. So coming back to coin example, this x could represent tossing a coin or flipping a coin, and you'll not know the outcome of that random process until that event happens. So that is why we call this variable as a random variable. And if you're talking about one specific event, for example getting heads when tossing a coin, then we'll be denoting that like this, where x will be equated to lowercase h, and that h represents the event that we are interested in. And the general formula to find probability is a ratio between favored events over all possible events. If we take coin flipping as an example and we are interested in finding the probability of getting heads, then it is going to be a ratio of getting heads over all possible outcomes, and in this case all possible outcomes are heads and tails. So it is going to be 1 over 2 and the probability is going to be 0.5 or 50%. Normally probability is measured as a range from 0 to 1. 0 indicates that the event will never ever happen, and 1 indicates that the event will happen with absolute certainty. So that is the range we use for probability. Now let's understand some of the concepts related to events and move on to more details into probability. First, let's understand what is mutually exclusive event and non-mutually exclusive event. Mutually exclusive events or set of events, they cannot happen at the same time. For example, when you are flipping a coin, you'll either get heads or tails. You will never get both of them at the same time. So that is an example for mutually exclusive events. On the other hand, when you are talking about non-mutually exclusive events, then those are the events that could happen at the same time. For example, when you are drawing a red card and a diamond card from a deck, then these are non-mutually exclusive events because all diamond cards are red cards. So the red card that you have drawn could very well be the diamond card as well. So those type of events are non-mutually exclusive events. We also have something called independent and dependent events. So when we are talking about independent events, then those events will not affect each other. For example, when you are flipping a coin multiple times, then they will not affect each other. I mean, the previous outcome of flipping a coin is not going to affect any future outcome. So those type of events are called independent events. But dependent events are events that will affect each other. For example, when you are drawing a card from a deck without replacement, then the first time you draw a card, you are drawing one card out of 52. But if you are drawing the second time, then you only have 51 cards. So the previous event has affected our current event. So these type of events are called dependent events. Now let's see what is marginal probability. Marginal probability is nothing but a probability of single event. This is what we have been seeing so far. It is like flipping a coin or drawing a card from a deck. All those are called marginal probability because we are talking about single event. And we denote that using this P function with one random variable as an input. We also have something called joint probability. So this is the most interesting one. In joint probability, we are talking about more than one event. So normally this is denoted using two random variables. In this case, I have used a comma b. And another way to represent this is using the set notation. We can also use probability of a intersection b. And if you see this Venn diagram, it will make things clear. So we have this red circle, which is probability of a, and this green circle, which is probability of b. And this section intersecting both circle is called probability of A and B. This is one example of joint probability. When we talk about joint probability, the mutually exclusive and the non-mutually exclusive events will have different outcomes. So if the events are mutually exclusive, then joint probability of them will be 0. Mutually exclusive means, think of that like, these two circles are not intersecting. So if they are not intersecting, the joint probability will obviously be 0. On the other hand, if they are not mutually exclusive, then a simple way to find the joint probability is first finding the probability of A and finding the probability of B, then multiplying them. So this will give us the joint probability for non-mutually exclusive events. So if you take this coin flipping as an example, you want to find probability of getting heads both times when the coin is flipped twice. So what you do is, you will first find the probability of getting heads first time. So that is going to be 0.5. And then you are going to find probability of getting heads again when the coin is flipped the second time. So the probability for that is again going to be 0.5. And if you multiply those two, you'll get 0.25. That will be the probability of getting heads both times when the coin is flipped twice. And if you see here, this is basically independent events. The outcome of flipping a coin the first time is not going to affect the outcome of flipping the coin the second time. So these type of events are, as we have previously seen, are independent events. And the formula for calculating joint probability when the events are independent is probability of first event times the probability of second event. And we could have multiple events as well. So joint probability is not just restricted to 2 events. We could have 2 or more events as well. And the formula remains the same. We find the probability for each one of them and we'll simply multiply them. So that is going to be the joint probability for independent events. Now coming to the dependent events, when the events are dependent, then the previous event is going to affect the current event, right? So we have seen that in the drawing card example, where if the card is drawn the first time, you are drawing it from the deck of 52 cards. But when you are drawing the second time, you are only drawing a card from a deck of 51 cards. So our probability is going to be different. And for these type of situation, we'll use something called conditional probability. So in this case, we have drawn B first. So B is the probability of drawing the first card. And the second time we are going to draw a card, which is probability of A, given B had already happened. The event B had already happened. So in this case, we have first drawn the first card. After that, we are drawing the second card, which is A. So which is denoted by this notation. And this is read as probability of A given B. It means that probability of A when B had already happened. So B is drawing the first card and A is drawing the second card. Probability of B, which is drawing the first card, is going to be 1 over 52. And probability of A, which is drawing the second card after the first card drawing has happened, is going to be 1 over 51. So basically, we multiply 1 over 51 and 1 over 52 to get the joint probability of dependent events. Okay. And like I said previously, this probability of A given B is called conditional probability. And a general formula for finding this conditional probability is probability of A and B over probability of B. Okay, so just to give you some intuition for this, let's go back to the Venn diagram. So we want to find out probability of A given B. Imagine that we are actually placing a dot in this rectangle. If the dot is placed in this empty region, then it's neither A nor B. Okay. If the dot is placed within this green circle, then it is event B. And if the dot is placed within this red circle, then it is event A. Okay. So now the probability of getting the dot placed inside this green circle is probability of B. And the probability of getting the dot placed within this red circle is probability of A. Okay. Now this intersection region is the joint probability, where if the dot is placed here, then the dot is placed in both A and B. Okay, so that is what this Venn diagram represents. Now we want to find out conditional probability of A given B had already happened, which means the dot is already somewhere within this green circle. Now we want to find out the probability of that dot being within this intersection region. Okay, because it is already in this green region, we don't know where it is. It is somewhere in this green region, and we want to find out the probability of that dot is within this intersection region, because this intersection region is the region which is overlapping with A, and we already know that it is definitely within this green circle. And if it is also going to be in red circle, then it has to be within this intersection region, right? Now, to find the probability of that, we just need to apply the same formula that we have been applying all along, which is favorable events over all events. So all event is going to be probability of B, which is this whole green circle, and favorable event is this intersection region, and this intersection region is nothing but joint probability of A and B. So that is why we have this ratio here. So we have probability of A and B, which is this intersection region, over probability of B, which is this whole green region. So that is going to give us the conditional probability of A given B. Okay, so hope this is clear. Let's move on to union probability next. So the joint probability is talking about two or more events happening at the same time. But you have multiple events and you want to find the probability of at least one of them happening, then you'll be using union probability. Okay, so you have many events and you want at least one of them to happen. You want to find out the probability of at least one of them to happen. So for union probability, the independence and dependence property of events are not relevant, so we can ignore them. So if you think about it, when we are talking about drawing a card from a deck, probability of getting a red card or a probability of getting a diamond card are not going to affect each other, right? It is still going to be 1 over 52. So that is why we are ignoring the independence and dependence nature of the events for union probability. But mutual exclusivity is going to matter. So when we are talking about mutually exclusive events, as in the events are not going to happen at the same time, example, flipping a coin, then finding a joint probability is simply finding the probability for each of those events and adding them together. For example, if you want to find the probability of getting heads or tails, then you're going to find the probability of getting heads, and then you're going to find the probability of getting tails, and you're simply going to add them. Because the events are mutually exclusive, you can do this. But when we are talking about non-mutually exclusive events, then the formula is still going to be same, but we also need to subtract the joint probability of A and B. Okay, so this is because if the events are not mutually exclusive, then we will double count some of the events. So for example, when we are talking about getting the union probability of getting heads in a coin flip and getting 1 when rolling a dice. So here, when you flip a coin and roll a die at the same time, you could have heads in your coin flip and number 1 in your die rolling at the same time, right? So if that happens, we should not count that as a 2 separate events. We still need to count that as 1 event. So the way to adjust that is by finding the intersection between those two and subtracting that from these two. Okay, so this removes the double counting. But we can use this as a general formula regardless, because if the events are mutually exclusive, the probability of A and B is always going to be 0. So this can still be used as a general formula for union probability in all cases, whether the events are mutually exclusive or not. Okay, so this is very, very high level informal review of probability theory. I hope this is useful. Thank you.